Hello everyone, welcome back to the channel. Myself Vasit Kumar, and today we are going to solve LeetCode question number 643. Maximum average sub maximum average subarray 1. The problem introduces one of the most important technique in DSA, the sliding window technique. Don't worry if you have never heard of it before. We will understand it step by step and solve it in CPP. So, we are given an integer array of nums, and a integer k. Our task is to find maximum average value of any contiguous subarray of size k. Let's understand with an example. So the first example is the nums array of 1, 12, minus 5, minus 6, 50, and 3. Here k is equal to 4. So possible subarray of size 4 are 1, 12, minus 5, and minus 6. Here, the average would be 0.5. The second subarray, which is possible, is 12, minus 5, minus 6, and 50, where the average would become 12.75. With that, the third subarray, which is possible, is minus 5, minus 6, 50, and 3, where the average is possible 10.5. So the maximum average is 12.75. Now let's think about the logic. To find the average, we must need the sum. Instead of calculating the sum of every subarray from scratch, we can reuse the previous sum. Suppose we are already known the sum of this window 1, 12, minus 5, and minus 6. To move to the next window 12, minus 5, minus 6, and 50, we will simply remove the element leaving the window and add the new element entering the window. This is called sliding window technique. Let's build the code. So first, let's calculate the sum of the first k elements. So int window sum is equals to 0. For int I equals to 0, I less than k, I plus plus. Here, window sum plus equals to nums. Sorry, here's a mistake. Oh no, 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 everything is fine. Nums of I. Window sum plus nums of I. Now, this is our first window. Let's store our first window. So int max sum is equal to window sum. Now move the window forward. For int I equals to k and I less than nums dot size and I plus plus. So we will remove the element leaving the window, which is window sum minus equals nums I minus k, and we will add the new element entering the window, which would be window sum plus equals nums of I. Now update the max sum. So max sum would be equal to max of max sum comma window sum. Now we will finally calculate the average and return it. So we will return, but we will do it in double for better answer, and max sum divided by k. Now we will test whether it passes the test cases. So as you can see that it has passed both the test cases. Now let's submit the answer. So as you can see that it has passed 128 out of 128 test cases. With that, it has surpassed 100% runtime. So here, the time complexity is O(n) because each element enters and leaves the window exactly once. With that, the space complexity becomes O(1) because we are using only a few variables. And that's it for this problem. The biggest takeaway here is that instead of recalculating everything, we reuse previous work by sliding the window. This simple idea appears in many coding interviews. If this explanation helped you, make sure to like the video and subscribe to the channel. Thank you for watching, and I will see you in the next video.